So, alright, welcome to the lecture 12 session 1, and we are going to start this session right now. So, hope I am audible. With that, I have asked earlier also, and you have replied that I am audible. And please confirm that it's audible. Is it audible? Okay, thank you very much. So let's continue. And in the last class, we were talking about the logical agents, and this class we are actually going to focus more on the finding inferences. Means when the knowledge base is given to you, that how you find out that what extra information that you can take out of the system. And also we would be seeing in this class about the first order logic, that is also a method to do a inference and find out the logical solutions, more representative language. So okay, let's start. So I would take you to this particular example that is not new for you, and we have in the previous class also seen this. This is a Wampus word. Here it's a kind of say 4x4 board, where in every board there is something that can be either a Wampus or some pits and some gold. And you are standing into some of the place, and now you have some percept, means you can sense that whether there is a breeze or glitter or smell or bump or scream. So these things you can measure. If any of these things happens, you can measure. So we have discussed this into last class in very detail, that your task is that there is an agent. He is in the location 1-1, and his task is to find out the goal. So if he is into a same cell where there is gold, so he can feel the glitter. If he is nearby the pit, then he can measure that there is some breeze. Okay, and if he is nearby a Wampus, then there would be some smell. If he wanted to move in a direction where there is a wall, then because he cannot go outside this particular chest or all these cell positions. So if he goes beyond this cell position, so then there would be some bump. And there is also one thing called a scream. That means he can listen the sound, and the sound is would arrive when because something he does, such as he can also perform a shoot. He can shoot the things into one. He have an arrow, so he can shoot that arrow in a particular direction. And in case if there is a Wampus, there he would die. And while dying, he would be doing a screaming. So if he screams, it means that the Wampus got died. All these things are there. So we have discussed this through the previous class. But now I want to bring you into this understanding that how we can represent all these information as a knowledge base, and how we can extract some information out of this. You know about this environment, that it is a single agent environment because only one single item is there. The deterministic means whatever things are there, they are not changing their position. Static things are static. Then discrete means deterministic means when you take a particular action, it happens. It is not like that it may happen or not happen. Static means everything is stable. Discrete means either you are into this state or other state. In between there is nothing. Not observable, because only things which are actually exposed to you, only you know about those things. You don't know about everything. Otherwise, there is no play. You would definitely go into a particular direction. You can find out the globe. It's not observable. Then only it's a question that you have to explore the environment. Okay. It's not episodic, means you cannot say that these are some step that you can follow to go ahead into particular direction. So you cannot create episodes. At every step, you have to take the decision. All right. So as I told you that whenever we want to represent any information in terms of the knowledge base, we define some of the variables. So let's assume that we have this parameter such as pxy. Pxy means if there is a pit in xy location, xy coordinate. Wxy, Wampus is there into the cell xy. Bxy, breeze in there into the cell xy. Sxy is a stench, means there is some smell into the room xy, okay, in the cell xy. So what we know these things. Try to see that we know that P11 is not. Can you see this? P11 not means what? What is P? There is a pit 11. With pit is there into 11. Which is the 11 cell? This is the 11 cell, na? So not a P11 means what? Not a P11 means there is no pit into 11. So is it the right thing to know? Is it the right thing? Do you know this? Can you see this? Yes? Alright. So I want to tell this thing that all these things, these are the information that we have. What all information I have. One by one I'm going to write this. So first is this, that the PR11 means there is a pit into 11. So is there a pit in 11? No. So I say that not a pit P11. Similarly, second information that I have is this, and this information is that B11 breeze in 11 implies what? And it is otherwise also in the both sides is implied, means if what is implies, if there is a breeze into 11, okay, it implies that there is a pit into 12 or pit into 21. So can you see this? However, there is no pit there, but this is a condition. This is a condition that if there is a, you know that this is the basic setting, that if there is a pit, you see that here is a pit. You see that here is a pit. So when you have a pit over here, so what is happening? All the nearby cells have a breeze. So it is telling that if B11, in case there is B11, in B, this is the cell. So it says that if in this cell there is a breeze, it means that there is a pit around. Okay. All right. So we one more sentence. One more sentence that we have is this, and I am going to name them. All these statements at this moment are named, and the B21 means breeze in 21. Breeze in 21 here means what? Either there is a pit over here, here, or here. In third place there is some pit. So B21 means the pit in 11, pit in 22, pit in 11, pit in 22, or pit in 31. So this is again, you can see that this is the valid thing to be written. So in this way you can see that so many things can be written now. Only not very limited number of things are possible, because for every possibility you have to write these kind of expressions. So a lot of this knowledge you need to write. And whenever I say that by using single thing, that whenever there is pit nearby area there is a breeze. So this single statement is actually representing so many statements. So you see that B11 breeze is in 11. And it is not, means there is no breeze. So this is actually what is the information. This is the actually categorized information that is provided to you. Similarly, R5 is the you say that this is the fifth statement that tells that B21 means 2 in 21 there is a breeze. So only this thing you know. Let's assume that this is all you know. All these things are known to you. There is some situation when these things are known to you. What is known to you? That there is no pit. There is no pit over here. Number one, and B11 is not there. Means there is no breeze over here. B21 means here is a breeze. Here is a breeze. This is also known to you by this. And for this thing, it says that if there is a breeze into 11, it means either into 21 there is a pit, or into 12 there is a breeze. Similarly, this 21 says P11 or P22 or P31. So you know all this, and that's very easy. I'm not going into the detail. So here you understood this. That's very easy. Okay. All right. So from here onwards, as I told you earlier also, that instead of using this statement, since I have given them name, so I may be using this particular representation R1, R2, R3. So if I say R4 means there is no breeze into the cell 11, like this. Alright, so this is what the situation is, that this is the information we have. So how many variables we have, how many variables, how many symbols we have, these are the predicates that we have, but how many symbols we have. So can you tell me how many symbols we have? So you can find out that how many symbols we have. Let me just tell you that how many symbols we have. So we have some symbol, this P11 is a symbol, B11 is a symbol, B11 is a symbol, P12 is a symbol, P12 is a symbol, P21 is also there, 21 is B21, B21 is also given, P11 already came, P22 is not came, P22 is again a variable, P31 is again one new variable, B11 is already there, B21 is already there. So how many variables we have? See, 1, 2, 3, 4, 5, 6, 7. So if 7 variables we have, so what we can do? We can assign true value to this, and true value to this, and false value to this, false value to this, true value to this. Arbitrarily I am assigning, okay, false value to this, false values to this, and because these are the situation possible, right? It may be possible that they are having true and false values, and then I would put these things into all the things and try to see whether all these relationships are satisfied or not. If all these statements are satisfied, it means that it's a valid board position. It's a valid board position. It may be possible that some of them are false. It means that no, this kind of assignment is not possible. This is not true. Means this is a bad idea. If this is what the situation is, knowledge is, if knowledge base is this, then in this knowledge base, this kind of assignment is not possible. Are you able to see that? So can you tell me how many different assignments I can do out of these variables 2 to the power 7? That is clear. Everybody knows this. Because 7 variables we have, so we can assign true, false, 2 to the power 7 kind of assignments I can do. Alright, so let me please help me to build this table. So let me just take this thing over from here and put it here like this, and let me take these variables and also put them here, and let me start making the table. Okay, 2 to the power 7 values I am going to make. Okay, so okay, alright, so I would make a table, and for each of these variables I would assign all possible truth values. Okay, so how can I assign? I can say it is false. Initially I should start from false. Okay, it's a kind of better way to tell you is this thing, that it's a kind of binary representation, means 0 0 0 0 0 0 0, then 0 0 0 0 0 0 1 next number. If you add this one, 0 0 0 0 1 0, then 0 0 0 0 0 1 1, 0 0 0 1 0 0. So can you see this? In this way you can write all these enumerations. So how many numbers would be there? There will be 2 to the power 7 number. Means for every number you can see that where is a true and where is a false. Okay, what is the next number? Just for sake of completeness, 0 1. What is the next number? 0 0 0 1 1 0. So similarly you can see that you can extend this thing. So 2 to the power 7 different values you can create, and because this represent this particular first line, that is all zeros represent this particular row. Similarly you can find out what is the representation for this thing, and so on. For everything you can find out this. Alright. So if you make these are the variables. Okay, these let's assume that for the sake of clarity, let I have made these formulas over there, B1, B2, B3. Okay, and the false, and false, true, and you know that what are the next thing, and similarly false, true, false, and there's some where there is false, true, false, true, and in every condition, and similarly at the end everything would be true. So you identify this table, this part. I think it's clear now. It's very simple that how we created this. So you understood this part, that how this table is created. Okay, this part is clear. Is it clear that how I created this part? Is it clear? Can anybody write yes? Okay, all right. So in every case, as I told you that whenever I am going to give an assignment, I told you now, whenever I am going to give an assignment, I want to test that what is the truthfulness of these relations. So I see that when all the values are false, when all these values are false, you see that here false, false, false. You say that R is true, it is true, it is true, it is true, but R5 is not true. Okay, so it means that this particular assignment does not represent the knowledge base. So here the knowledge base is false. Can you see this? Can you understand this part? I think it should not be difficult. Similarly, the second assignment where false, 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 and at this position there is true. You see that the R1 is true, R2 is true, but R3 is false. R4 is true, and R5 is also false. So all these statements should be R1 to R3 should be true because it's my database, it's my knowledge base. They cannot be they cannot be false. So you see that here everything is, therefore if any other statement got false, so I say that knowledge base is not accepting this thing. It's not true. All right, you come into this table and try to go down, and then you see that okay, this is a special kind of assignment which actually has some assignment. I'm not going to detail that what is the assignment, and in this assignment what is going to happen, that this part becomes true. Only on these three places you see true, otherwise all other places there is a false. Okay, you by yourself can enumerate and try to see this, that because this table is going to be long, we cannot put everything over here. So you see that everywhere there is a false. Only three positions are there where it is true, and therefore they are important. Means this is what the real assignments are. Means these are the real things that are possible. Okay, these are things which are possible into the system. They are acceptable by the rules that are given to me. So if you just analyze these rules, so you can see one thing, that that C P12 not P12 not P1 P12 C P12. What is the value in all these three cases? You see the false. Okay, P12 is false. Okay, P12 is false means not of P12 is true. Okay, not of P12 is true. So what does it mean? P is, there is a pit, okay, into the 2 1 location at this particular location, P12. P12 means what? There is a pit into this particular location. Okay, there was a pit into this particular location, and we have seen that if all these equations are true, they make a condition such that this is everywhere false. It means that there is no pit into the location 1 2. Are you with me? Correct. All right. You are absolutely right. Some students are writing the same thing. That you see that when you see that what you have to see in this particular complete assignment table, you see that what are the assignment for which this knowledge base is true. When you see that these are the three assignments, only these are the three assignments, so then for all these three assignments you see that there is a false, false, false. Look, B11 false means what? There is no breeze into there. So this should be there because this is the information provided. B21 means there is no breeze into 21. So this is also a given information. Okay, but this P11 is false. There is no pit. This is also given information. So you can see that there are multiple things that you can see that P12 means there is no a pit into 1 2. So I think P12 is P12 is, let me go back, P12. So you can go into this particular direction. Therefore, agent would move into this direction. So you have seen that one thing, that given the information, how you can extract new information. All right. So given this information, this was a one way to extract this information that there is no pit into the 1 2. Therefore, you can go into that particular cell. All right. Okay. On the other hand, if you see this another variable P22, here you see that one place it is false, other place it is true. So therefore, you cannot by 100% sure you can tell that because all these things are valid assignments. So in some assignment there could be a pit, and in other assignment there could not be a pit. So you say that it may be possible that the system could be into this state, because this is also acceptable state. Then I cannot definitely tell that I should take the step into the 2-2. So you would not go using this information. You would not proceed towards the 2-2. Okay, but you can proceed to the 2-1 and 1-2, because that all these things you can see that all the things are false. So this is the same thing written over here. So hope it is clear to you that you have seen one thing in this example. You have seen in this scene that if this particular word is given to you, then how can you create a system by which you can represent the knowledge. So this was the one way that created you knowledge. And when you have some knowledge, then how you can create the table and come up with some of the understanding, such as here we have come up with the understanding that there is no fit given this information into 1-2, and therefore you can take the step forward. So one way. All right. Okay. Now you would talk another thing that is a very important and easy thing, and one is the validity and the satisfiability. That whenever a sentence is given to you, for example, this is a sentence A or A naught. So sometime you know what is the model. Model is a particular assignment. Okay. So all these things are actually models. In every line is a model. So it's a kind of you should understand that if I write A or not A, so in whatever assignment you give to the A, this particular statement would be true. Can you see this? Okay. Whatever assignment you give, okay, whatever assignment you give to the A, because if I give you this statement only, A and not A, okay, if I give you this assignment, so how many variables you have? A, single variable. How many assignment are possible? 0 and 1. When you assign 0, what would happen? It would write 0 or not of 0. When you assign 0 and 1. When you assign 1, it becomes 1 and not of 1. So you can see that 0 is 0 and not of this is 1. So therefore ultimately this equation comes out to be 0 or 1. And similarly, this what happens with this equation? It becomes 1 or 0, because this becomes 0. Okay, 1 or 0 means 1, and 1 and 0 is 0 or 1, or 1 or 0, both are going to give you 1. So therefore this statement is always true. Okay. Similarly, see another statement, that is A or B implies A or B. So can you see that whether what is the assignment? What is the assignment possible? Okay, let us try to see. Okay. Okay, so let us see for the AB what all things are possible. So you can see like this, that you write A and B, you write A, you write B, you write A or B, you write A or B again. Okay, and you create this table. This is just a copy. Okay, so it says that what are the values possible? 0, 0, 0, 1, 1, 0, 1, 1. So let me draw this line, and I would say this thing. What is happening? I got a question. Let me just see this. Sir, a question. In this table is only for when our hero is in location 1, 1. In other location, there will be totally different variable in the different table, isn't it? Yes, all right. Because because even in this situation, lot of other things would be there. Okay, in this situation also lot of other variables would be there, but for the sake of simplicity we have removed them so that it looks simple and you can write them. Okay, and every time making truth table is not a good idea, because lot of variable would be there, and how can you create all these things for them? So we will be seeing that what is the better way, but yes, you are perfectly right, because we have only represented some of the things. Alright, so can you tell me what is the A or B? A or B is 0. Then again here I have to copy, and A or B is 1, 1, 1. And now I have to find out, let me call it X, let me call it Y. Now I have to find out what is X to Y. Here I write X implies X to Y, X implies Y. what is the value. Okay, so you know that x implies y given x and y. What is the value for x? X implies y. You know this now, because input could be 0 0 0 0 0 1 1 0 1 1, and here you see that when it is 1 0 then it is 0, otherwise always it is 1. This is what the table is, truth table is, you know this. Okay, this is the truth table is. So here the condition could be, you know that whenever I am going to copy this, it is going to be 1 1 1. Only two condition, 0 to 0. This is what in this case, what are the positions arriving? This is the position arriving here. So here you see the output is 1, and the second thing 1 to 1. This thing, this arises, that is also 1. Okay, both the places there is 1. So you say 1 1 1. So you here also you see that in this table everywhere there is 1. Okay, every time it is 1. Okay, you see na, every time it is 1. So such a statement which are always true in all the assignments of A and B, they are called valid statement. Okay, or tautology. The another name is the tautology. So these two statements are tautologies. So if you want to show that something is tautology, one way that you can create a this truth table, and you show that everywhere in all the assignments the value is going to be 1. Next question is this satisfiability. The satisfiability you have to tell. Satisfiable formulas are those formulas which actually when there is a possibility that you can assign, in some places you can find out 1. What do I mean? I mean this, that in a similar way, let's forget about that what was there. Just only consider this particular part. Okay, just only consider this particular part. Only consider this particular part. You see that there is an example where everywhere there is 1. So you can assume that there could be another position where everywhere it is 0. Was it possible, na? Because if everywhere 1 is possible, so everywhere 0 is also possible. So such a statement, can you give me a statement that is everywhere possible, everywhere 0? So whatever equation you write, I just write and 0. It is everywhere 0. Okay, I write and 0. Okay, and if you not satisfied with me that how can I write and 0, then you see that you can find out the representation of this 0, and you can see that this, you can see na, there is a 0. 0 can be created by x implies y. You say that x implies y, where you put the value of y. These are the new variables where you put y is equal to 0 and x is equal to 1. Okay, similarly you can find out with the same variables you can find out a and not a and not of a. Similarly you can write like this also, and this will also give you 0. So you can multiple ways you can find out that all the things are 0. So my problem is only this, that if your table is such that all the places there is 0, then you cannot find out any assignment of these variables so that the output becomes 1. Okay, in all other cases at least you can find out one such assignment where there is 1. What I'm telling that if it is not the case that everywhere there is 0, then at least there would be somewhere 1, and that line would give you that what is the assignment that makes this variable 1. So you can find out always such assignments. So if you have a formula and you see that there is a possibility that you can assign some values so that the formula becomes 1, such a formula is called satisfiable. Okay, a valid formula is also satisfiable. Okay, but valid is always true. Whatever assignment you do, it's always true. But satisfiable, you have to find out that what I have to put, because if A implies B, it is, you say that if you assign here A is equal to 1 and B is equal to 0, then it's not true. Okay, so you have to go for the another assignment, and when you see that okay, yes, there is one assignment possible, then you are done. So now my question is, determine whether the following sentence is valid or satisfiable. So my question is, so can you solve with me? Can you find out this, whether this statement is valid or satisfiable? This is the question. Can you solve this question? So alright, okay, you can solve. I think so. Let me just tell you one thing, that I would be doing half of the thing, and rest I would give you as an exercise. So this is what I want to find out, how many variables we have. help me to find out. So I have one variable that is A. Okay, another variable is B, another variable is C. A, B, C we have. Okay, so we are going to assign some values to A, B, and C. Okay, then I need to find out A and B, and then if I say it X, then I have to find out X implies C to find out the value of this. Then we have to find out B implies C. B implies C to find out this. Then I have to find out A implies Y if I say this Y. Okay, and then I have to find out if I say this thing A implies X implies say as a, if I say this as a Z, and if I say this as a K, then I have to find out Z double implied K. So this is the table that all I have to make. Okay, so I have to make a table like this. Okay, I have to make a table like this. For the truth table we have to find out, because ultimately if everywhere there is one, at least one place I can find out one, then I can say that it's satisfiable. Everywhere if I get one over here, everywhere there is one, then I say that this thing is going to be valid. So alright, so can you give me what all the assignments here possible? I think you can write better than me. Help me. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 1 1 0 1 1 1. This is all the assignments are. No further assignment. For everything you have to find out that what these values are. Okay, so I would not go for everything. I would just solve for one. So let us solve for this thing. Randomly I am picking this thing. Now, what is A and B? Can you tell me? A and B is 0. Alright. Can you tell me what is X implies C? Means 0 and C. 0 implies 1. What should be here? Can you help me? No? I'm not getting answer. Please write. 1. Alright. 1. Because you know that Z implies C. 0 say 1 gaya, so then it is 1. I have to find out B implies C. B implies C. B implies C. 1 to 1 is 1. B implies C is 1. Similarly, here we have to find A implies Y. A implies Y is this. A implies 0 to 1 is 1. Okay. Now you have to tell Z and K, relationship between these and things. And double implication is, what is double implication? And you say that A implies B and B implies A, like this. Okay. So Z implies K is actually, let me just write into terms of Z and K is only, so that it remains into the context. So it is actually Z imply K and K implies Z. This is what you have to write. Alright. So Z implies K is what? Can you tell me what is Z implies K? Z is this, and Z implies K is 1. This part is 1 and K implies this 1 to 1. It is again 1. You need this table 0 0 0 1 1 0 1 1. You know this table 1 1. This kind of table it is, na 0 0. So you find over here 1. Okay, this is what you got it here. So I think that you can solve by this table, and at the end I don't have this answer right now, and also it is not required. That if all these places you get 1, all 1, then what is going to happen? It is valid. If it is all 0, then it is unsatisfiable. Otherwise satisfiable. Alright, you go into this way. So now with this thing you can find out that whether the equation is satisfiable or not satisfiable. This is a very simple question. Next thing that we want to talk is that we want to discuss forward chaining, because sometime modus ponens, that is this particular formulation, you know, if phi and the phi implies psi, if both the things is given to you, then you can say that if phi is there and phi implies psi, it means what? Psi is there, because phi implies psi. So if this is condition you see that, then phi is there. So it is a very good thing to see that in the chat nothing is there. Okay, all right. So most of the time applying modulus ponens would be helpful, because when you try to solve something and find out something, writing all the truth table may be very difficult. So for those cases, sometimes modulus ponens can be helpful. Let me tell you how. So let's assume that these are the things which are given to your knowledge base, and now you want to find out that what is the thing that comes out of this. Okay, so let's assume that we want to find out, determine if a single propositional symbol q is entailed by this knowledge. Achha, q comes out to be means you want to find out whether the value of q is 1 or not. Okay, so you see that some facts are given to you, and all these things are given into this form. So, and you sometime you can apply modulus ponens and you can find out. So one way to find out this thing, there are two ways, and we will be discussing both of them today. So one method is a forward chaining. The forward chaining says that you apply modulus ponens. What is the modulus ponens? You know, we have discussed just now, and it tells that if you have phi, so if you have phi and phi implies psi, then you can say that you have phi. You have psi. Okay, this is all clear. So let's assume that this is what the knowledge base you have. A given means, please understand, A given A means A is equal to 1. Given B means B is equal to 1. Alright. So you say that you put in the forward chaining, you put that you have the value A, means A is true. You put that you have the value B is true. And you say, since this particular line says A and B gives you L, means A and both the things should be there, then only you get L, otherwise you would not get L. How can you get the L? Because even both the things are there, and you see that here both the things are there, and it's a AND C that give you L. And then next thing says A and P gives you L. What is P? I don't know. Let me write P somewhere. And we don't know what is the truth, but somebody tells that it given the A and given the P, both the things, this particular statement second, would give you L. Okay, so it means that it should also reach to this particular place. Means L can be found out in this way also, that L is equal to this if you have this thing. But L you have achieved because A and B are there, therefore, and this is a AND tree, both this should be true. See the third line, B and L is equal to M, means you take something from B, you take something B and L, and it is an AND tree, then you get M. Okay, from this you get M. Simple? Okay, simple. Next line is L and M gives P. Okay, L and M, these two things, L and M, and they and L and M gives you P. They gives you P. Okay, so let me just, for the sake of clarity, let me draw the boxes also so that it becomes clear. You get P. And next thing says that P gives you Q. So P gives you Q. So if there is a single thing, so no need of other connections. It gives you Q. Okay, it gives you Q. So do we have this? The point is, do we have this? Can we find out like this? Can you find out, infer that there is a Q, because all these things are given to you. What you know, that this thing is green, means this thing you know, this thing is given to you, this thing is given to you. If both the things are given to you, then this particular tree getting energizes, and therefore you get L. Okay. Alright. When L and B are given, it means that this tree gets energized, this tree gets energized, and because AND is complete, then what you get? You get M. Okay. And then again you see that when M and L are given, these three M and L are given, then these three get energized, and you get P. Okay, you get P, and when you get P, then this tree get energized, and you get the part as a Q, and therefore you got the Q. So same thing that I made into this this way. it is equivalent to the same thing. It is the same thing. So similar diagram you can also draw over here, and you can see that how you can find out this kind of representations. All right. One more way, let me tell you that how you can go ahead with this is this, that initially you actually another way to come up with this to give the solution to find out whether the Q is there or not is using some. Let me just control set. Let me just take it here to here so that it remains. Let me remove so that I can get some space. Another way is this, that you create a, for everything that you have, you create a data structure. Especially, it is a special kind of data structure that gives you that what are the propositions you have and what is into head. Okay. So you see the propositions and their head. So this is a proposition you see, and what is this proposition? Means given the P, you have the value Q. Okay. What is the other proposition? Given L and M, you have the value of P. Okay. You have the value of P. And what is the third one? Given B and L, you have the value of M. What else you have? Given A and P, you have the value L. Given A and B, you have the value L. Please be with me because I do a lot of mistakes. If I do some mistakes, please let me know. Okay. And some direct facts are given to you, and these things we put into agenda table. This is a data structure that I'm going to use. In agenda table, whatever we have, for example, A we have, B we have, these things we know. We put these things into agenda table. Now, my thing get started. The algorithm says that initially you create this kind of data structure. Then what you do, you take one item from here. Okay, A, and you remove everywhere if there is an A. Okay, all right, you remove everywhere from where there is an A. All right, I have done it. Okay, all right, are you with me? Anybody? Can anybody write yes? Do you understand this part? No. So that's very simple. That's very straightforward. That initially, for given all these proposition, we have created this table. That is. No. Somebody is telling no, but no. It's not to be sorry. Please ask the question. Okay. I would tell you once again. Okay. When you would say yes, then only I would go. But it's your responsibility to tell me yes. Okay. These are the propagation given to me. Right? Yes. Okay. These are the propagation. Okay. Take the first proposition. P implies Q. So this part means what you get. I am going to put into the head. You get P given the you get Q given the P. Is it? Can you understand this part? This line? Can you understand this line? Huh? Yes. I want to answer for Markandeya. Can you write yes? No? Okay, all right. Then all right. See this. Only see this part. Okay. Here it is written P gives you Q. Okay. So this part, whatever the second part is, means what you get, I am going to put it here, and what are the things required, I am putting over into the first part. Is it right? Now you understand? Okay. So Markandeya, tell me that this is the second one. Okay. Here L and M gives you P. Okay. So what you want over here? What would be into the head? Is it P, right? Is it P, right? And this side L and M. All right. Okay. Similarly, you can find all these things. Should I explain more, Markandeya? Should I explain more? You understood this thing? You can create this table. Yes. No need, sir. I understood. No, that's fine. This is the fun of this class. Okay. So this is we have done. Okay. We can create like this. Now I am telling one more thing, that A and B are there, which are actually direct information. Those things I am going to put into the agenda table. Now I am ready to solve this particular problem. Okay. So A and B I am putting into the agenda table. Why? Because they are directly given to me. Okay. This is our agenda to find out that what is the truth. So I have seen that A and B are given truth. So I am taking that these are the truth. That's it. All right, Markande, is it clear? This part is also clear. Isn't that able? Okay, let me go ahead. Now I am going to tell you the algorithm. Algorithm says that remove the first item, and whatever the place it is, you remove this part. This you understood? Very simple. All right. So we have done it. So first step everybody understand. So let us go for the second step. Second step says that whatever is on the top you remove this. I have removed B, and similarly I would also remove B from here, B from here. I have removed B. In case while removing you see anything that now everything is satisfied, because in here you see that everything is satisfied, so it gives you the L. It gives you the L, and therefore you would also put, because you find out this, you have discovered that you have find out L. Understood this thing? Because it means that all the preconditions are satisfied, therefore I also have the L. So L you have, you put the L over here. Now you continue with the algorithm. It says that you remove the L from here and remove any L from here. You see that one more thing you have discovered. What is this? M. You put the M over here. All right. Now it says that the algorithm says that you remove the M and remove the M from this side. You remove the M from this side. Okay. Do you got anything? We need to remove L also. We need to in the second row. Acha, okay, fine, good. Okay, sorry. While I was removing this, I forget to remove all the L. So this was my mistake. So when I have forward removed this, that's why I am telling that. Please be with me so that if we do any kind of mistake, so we can correct it. All right, very good. So if I had removed this, then this has been already been removed, and in this step when I have removed M over here, I got new item that is P. Then my task is that what I would do, I would put the P over here, and then I would go ahead with the next step, and in the next step I would remove this particular P also, and I would remove this P and this P. What all I get? I get L and P, but L already has been removed, so I got Q. Okay. So I would put Q over here, and I can see that okay, Q can be reached by all these things. So this is the one way. This is a better way to find out that what I can do. So you have seen that this is the proof that you can find out the Q, and the Q is true. Is it clear? Okay. Determine if the single proposition symbol Q is entailed by the knowledge or not. You have find out. Yes, it is entailed. So, all right, at this moment we would be taking a small break, and in the next slide, I think next slide is the backward chaining. This is the forward chaining. In the next slide, we would have the backward chaining. I would keep this slide with you and see this slide, and we can come and discuss similar kind of things over there. Thank you very much. We are going to have a small break at this moment. Any questions, please?